But what it's actually doing is installing malware. And threat actors know this.
Welcome to the Gen AI Security Project Threat Intelligence Podcast Series, Episode 10.
And so what's interesting about this kind of a supply chain attack within a supply chain attack led to the theft of, I believe, $12 million in crypto.
Where expert hosts Rachel James and Dr. Bryan Nakayama, co-leads from the Gen AI Security Project Threat Intelligence Initiative, share the latest and greatest on AI threat intelligence. The opinions expressed in this podcast are theirs and theirs alone and do not reflect the opinions of the organizations through which they are employed. Welcome back to the Threat Intelligence Podcast, Episode 10 with Bryan Nakayama and Rachel James. So I love it when we're working out what we're going to be talking about in an episode. And I get a note from you both saying something like, we're going to be talking supply chain and about the Five Eyes warning. Yeah, that sounds so cryptic and dangerous already.
Yeah, that's a good way to describe it.
So let's start with supply chain. There was a lot of something called supply chain attacks. Can you tell me what that is and why does it matter for those in cybersecurity?
Yeah, I can take that. It is a fairly big umbrella term, but a supply chain attack basically happens when an attacker can't or won't break into your systems directly. So instead, they compromise something that your systems already trust and already depend on. So a piece of your system, right? And so that might be a vendor, that could be a part of your code that's using something that we call a library, or even an extension. That could be a build tool, or even an update mechanism. Some of the most famous supply chain attacks were when an update that was pushed to a piece of software contained malicious code. So for an attacker, that's amazing because you install their malware for them. They don't have to worry about initial access or figuring out how to get it installed. You're doing it for them. And for AI, a really simple example of that might be something like, those MCP servers or the plugins that you see when you're going into Claude or your various AI tools. Well, those little add-ons that you might use, what happens if one of those add-ons has code that's malicious?
So is it like instead of robbing the bank, you bribe the armored car company?
Yeah, exactly. So you're attacking or you're compromising like a part of the system that's generally considered trusted, right? And as you can imagine, now that AI has made producing code and applications even faster, now that we have vibe coders reviewing that code to see if AI has pulled in something from the internet that was written by someone else that could be malicious, that review process is an increasing bottleneck. When people vibe code, AI is making the decision about what to code. It's being able to reference basically the entire internet's worth of code examples and libraries to use. And so it'll try to pull things in to make your application run, and it can easily pull in something that's malicious. So AI might just think it's pulling down a library to do something like perform some basic statistical analysis that you need for your application, or provide connection from your AI system to some other system that has data that you need. But what it's actually doing is installing malware. And threat actors know this, right? So they know people are vibe coding, and that vibe coders don't typically have the same level of skill set to be able to look at their code and what's making up their application. They know that there's an increasingly large volume of people who are vibe coding applications at companies, and so that there's far more people who have this ability to vibe code than there are people capable and available to do a security review of that code. So it's a bottleneck now, and they're starting to exploit that.
Yeah, so I was going to say, I think it's worth reviewing, kind of a few recent supply chain incidents that have happened. So I'll kind of start, this is an interesting one. This is a, attack method that was discovered by a company called Novi, which they call Cordyceps. And basically it relies on insecure CI/CD pipeline. So basically just think about this way that, software development occurs. And so the really interesting thing is that this vulnerability means that anyone with, a GitHub account can go in and trigger this, kind of CI/CD or software production pipeline and basically sneak in malicious, code and commands into that pipeline, right? And so that basically relies on the implicit trust that when, say, someone wants to contribute to an open source project, they do like a pull request on the code, that triggers a script that runs, right? And that script has elevated permissions that may not necessarily go typically to the user who's like looking to contribute to that open source project. And so therefore it allows them to kind of get elevated permissions, like I said, kind of insert sneaky commands. And so the hard part is that, each step looks fine, right? It doesn't necessarily look like it's malicious from the surface, but it's the fact that they're able to exploit that trust that's put into the CI/CD scripts that are held in repositories like GitHub, right? And so Novi, did go out and try to figure out how many companies are vulnerable to this. They found 654 repos covering Microsoft, Google, Apache, Cloudflare, and the Python Software Foundation. And they confirmed 300 of them are kind of fully exploitable versus this method. And so, this kind of, again, comes from the velocity of code mentioned by Rachel that comes from vibe coding, where you have AI coding assistants generating these CI/CD pipeline configurations at scale, reproducing these same insecure patterns, right? Without, the ability to kind of go back and review that, or I should say, without kind of catching that. And it's like kind of overwhelms the ability for people to go in and audit it, right? Again, that kind of code velocity overwhelming people's ability to make sure that it's secure.
Yeah, and there was another one that also happened. It was just, man, the past few weeks, there's just been a lot of these. So the one I would bring up is the Miasma worm. And this was interesting to me because this was actually hijacking AI coding tools directly, right? So there was a malware family called Miasma that compromised 24 NPM packages across 2 different software ecosystems. And for those folks who are not intimately aware, NPM packages are incredibly common in almost everything that you could code, right? It's one of the most common packages that you would find at that an application developer would be calling down. And so Miasma evolved beyond sort of poisoning these package registries. It actually, this malware directly hijacked AI coding assistants at the tool level. So the AI coding assistant was involved. What would happen is if a developer cloned an infected repo that had this Miasma malware and opened it in Claude Code or Cursor or VS Code, any of the plethora of AI coding environments, vibe coding sort of assistant environments out there, the tool itself, your Claude Code, your VS Code, could be compromised. So this really meant that any developer who's using AI coding tools on open source projects, especially if you frequently clone external repos without scanning them first in order to start using them, which is not a best practice, but a lot of people do that as a general shortcut. You could encounter this inside of those you can encounter this malware inside of those repos. So it was really interesting because this shifts the threat model, right? Which, the thing we've been talking to the developers about and sort of the through line that we've heard for years and years is just don't install bad packages, right? We're mostly concerned about installing bad packages, but now it's don't open untrusted repos in your coding assistant. You need to scan that entire repo before you open it inside of a coding assistant, because that itself could actually hijack that coding assistant, which is a pretty powerful tool to have in the hand of threat actors.
Yeah, and so I was going to say there's one final one that I think is also worth noting, where you saw famous Chalima, which is the CrowdStrike designator for a North Korean actor, using an agent running Claude's Opus model. They didn't specify which one, in order to insert malicious NPM dependency into a legitimate developer project back in February. And so what's interesting about this, right, is it's kind of a supply chain attack within a supply chain attack, where they first took a malicious dependency right through the supply chain, put it into a developer project, which was then used downstream by other users, which led to the theft of, I believe, $12 million in crypto. This is kind of classic DPRK in terms of motives, right? Always seeking to steal crypto. But what makes it really interesting, right, is that use of the coding agent to inject that malicious dependency, right? And so that's why, kind of makes it particularly unique and fascinating. And so if we want to think about the broader implications of this, right, to kind of echo some of what Rachel said, right, like, attack surface is no longer just the code itself, it's the tools and pipelines that process that code. And that, detection really requires behavioral analysis, the AI tooling layer, not just scanning for malicious dependencies at all time, right? And again, this is just the world we're facing as that volume and velocity of code expands rapidly, right, allowing, making dependencies, supply chains, et cetera, kind of very, kind of useful attack vectors for threat actors, but also, kind of tempting targets.
So what does all this mean? Is there like a son of synopsis? Because it sounds like supply chain attacks are really sneaky, and it doesn't sound like the fix is easy.
Yeah, I mean, definitely. I think one of the things that people really need to take away from this is that threat actors are aware that AI is often, people are often choosing speed over security, right? So the speed at which vibe coders can introduce malware into their applications and therefore into your organization is far, far faster than the speed at which we can build detections using behavioral analysis. We can examine our CI/CD pipelines to review all of the packages and the repos that are being pulled down and perform code reviews of the finished product. So, the even just building the detections actually requires a lot of actually understanding the purpose of the app or the agent itself as well. And in many cases, not all of the detections that you create can actually be generalized across an entire population of applications at the enterprise level. So we're talking about very bespoke level detections that you have to write per application. Again, this basically means that we have a much larger funnel of things that are coming in to a bottleneck that has, and that security review bottleneck has an increasing scope of things we have to be worried about. So this is going to be a really tough challenge, especially for resource-constrained security teams.
And you talk about organizations, and this, maybe you could give some sort of perspective on that. It sounds to me it could be anything from the Special Olympics to, Jim's custom denim wear. I mean, it could be anything. Are you saying organizations? Is that correct?
Yeah, I mean, definitely we see this across the board from small organizations to large organizations. They are looking to save money and to accelerate their business by taking advantage of the fact that they don't have to hire a 12-year seasoned developer to write an application. They could have it vibe coded. The problem is that means that the speed of business is able to produce things that need a security review to ensure that it's not going to introduce a vulnerability into your organization. And the way threat actors are aware of that and that they're leveraging these sort of trusted components, these sideways methods of introducing malware into a coding environment, where we have more things coming into the funnel. We have more things that we have to look at during that funnel, and they're being much sneakier about it. So, all organizations who are looking to accelerate their business and think vibe coding is the answer, they really need to stop and think about, you've actually just shifted, for a large part, you've shifted a lot of the effort that needs to take place in vibe coding to the actual review and the security constraints that are around that development pipeline. And so if you're not prepared to make that shift with your resources, and you're not prepared to deal with this new reality of the way threat actors are thinking about it, that means you're going to be introducing significantly more risk into your organization.
And those organizations might include charities and nonprofits. So let's leave it at that. And I wanted to ask you something about this other thing you mentioned, Five Eyes. What is that? It sounds like something out of James Bond and without the upside of a cool Aston Martin.
Well, yeah, you're not too far off, actually. So Five Eyes is an intelligence alliance, and it's made up of the US, UK, Canada, Australia, and New Zealand. They're an intelligence sharing organization. I think originally they did kind of old-fashioned signals intelligence, but they're one of the most prominent in the world. And some of the intelligence that they share does include cybersecurity intelligence.
Yeah, I was gonna say, typically these agencies will, kind of issue individual, or maybe they'll partner up like with, another. But it's kind of rare to see the kind of full Five Eyes putting out some sort of advisory. But what we had here was, last month a joint advisory between all the members that issued a pretty dire warning about AI being used for cyber attack.
It seems serious, Brian.
Yeah, no, so this is, clearly in response to the release of Anthropic's Mythos, right? This kind of broader debate about AI cyber capabilities, right? They write that, AI models will fundamentally transform both offensive and defensive cyber, and that the timeline is not years, it's months, right? And so in particular, the reason for this is that they highlight Mythos's capabilities to chain exploits adapt to defenses to real time, and scale operations in a way that human teams couldn't manage, right? So basically being able to work at machine speed rather than human speed. And in particular, they kind of cite the traditional set of adversaries as being the most likely beneficiaries, those adversaries being China, Russia, Iran, and North Korea. Right. And so at the same time, as part of this broader response to kind of Mythos and the kind of increasing capability of frontier AI models, we saw CISA, which is the US's kind of domestic civilian critical infrastructure protection agency around information security, kind of set a deadline for government agencies to remediate serious vulnerabilities to 3 days, citing this. And so, to think more broadly, this is kind of a strategic organization for thinking about the broader, cybersecurity landscape, right? As that gap between vulnerability discovery and weaponization is rapidly shrinking, and you see the increasing, kind of automated orchestration of attacks. Right. So, what can we do? So, enterprises, the concrete recommended actions from the Five Eyes included, things that were fairly basic, right? You got to be good at your basics before you can really defend against the bad stuff. So just things like reducing your attack surface, accelerating your patch cycles, enforcing, principle of least privilege for identity controls, and assuming that any tool holding credentials could be weaponized. And so, the other part of this too is thinking about, okay, what happened, right after, right? You see OpenAI's GPT 5.5 come out, which is supposed to be, nearly Mythos class. And then more interestingly enough, you see an open weight model come from a Chinese firm that's called GLM 5.2, which I think in many cases may potentially have a bigger impact than Mythos.
Really? Open weight? What does that mean? Why is that important?
Yeah, so basically an open weight model means that you can just kind of go out and download the model itself, right? You don't need to have gated by a provider. Like, so for example, I can't go out and download Mythos and run it on my own machine, even assuming I had the most powerful consumer computer possible, right? I just can't do that. I can't go out and download it. And so what's important here is that this is, a model which is claimed to be approaching Mythos class in terms of capabilities that anyone can go out and run, right? Now there's some caveats about that, which we'll talk about later, but if we think about it on that kind of broader strategic level, particularly given the fact that the last few weeks we've been talking about export controls, does this mean that, the genie is out of the bottle, right? That we can't control advanced AI cyber capabilities in quite the same way as we're expecting when they're being closely held by major frontier labs, right? And so if you see, these kinds of comparable models being shipped outside US jurisdictions, does it matter that we're restricting people from outside the US using Mythos? Something like that.
Yeah, and I definitely want to sort of caveat this and frame this a lot, because it sounds like we're sort of advocating that the best approach here is horses out of the barns, out of the gate, and might as well let everybody have these super powerful models. But we've talked about this a lot in our research and our experience. Bryan and I have had some hands-on with these tools and studying their offensive capabilities. We've shared multiple times on previous podcasts other experts who've shared and emphasized that downloading frontier scale weights or open source models that's not the same thing as wielding them effectively, particularly in offensive security purposes, right? The compute, the expertise that's needed, particularly the harnessing and the scaffolding of the agentic systems, that still is a huge gate. That's still a huge barrier to sort of widespread use of script kiddies being able to use these things to bring down the Pentagon or something, right? So it's not that we're making every script kiddie have sort of a saying this makes every script kiddie have an unsupervised mythos level class model that's for free. But it does mean some of the government efforts that we've talked about in the past few episodes that we've reported on, where they're trying to sort of provide gated controls or attempting to control frontier model in this way. It sort of loses some of or much of its strategic bite.
Yeah, I think that's one of the questions. I think the average person probably not going to be able to get enough the high end enough graphics card in order to run this, right? But again, it goes back to this broader idea that once you have the model released, it's going to be mirrored, it's going to be everywhere, so you can't necessarily control it, right? And then who's going to benefit? Most likely those adversaries that we mentioned before: China, Iran, North Korea, etc., who are able to afford the setup and have the human capital or the kind of skilled enough operators in order to usefully, kind of employ an open weight model, right? So it should be noted that, some of the benchmarks around GLM 5.2 are contested. There hasn't been a bunch of testing, let's say that we can do comparatively. But the point remains that it's a highly performant model and is probably kind of a signal of things to come, which is to say the continued expansion of frontier model capabilities, into the open source as those models kind of come up to parity. And so, kind of a, more interesting strategic level, right? We can think about this as basically a form of asymmetric competition between China and the United States, where China encourages open labs to release these models in order to undermine the US AI lead, right? And so it's a really interesting, kind of intersection of our topics with, kind of very high level interstate competition with the more kind of, let's say, let's be very clear, it's still exciting, but the kind of banal, kind of ability for, like a threat actor to be able to run their own extremely high-end frontier model system, right? Latter is unlikely, right? But it shows the kind of very interesting world of AI cyber capabilities.
So what should cybersecurity leaders and experts be thinking about?
So I think, again, the, cybersecurity leaders should be thinking about the fact that, they're not necessarily always going to be able to get access to models from kind of, let's say, high-end frontier labs because of the various kind of, controls that we've discussed before, right? And then on the other hand, that, definitely open weight models are something that's worth exploring, however, with appropriate vetting to make sure that, there aren't kind of, various, let's say, I guess we would call them guardrails, but certain kind of like, forms of like training that are inserted in order to kind of shape their output in a way that's in line with, let's say, the kind of political environment that they're being released in. See, for example, China, right? But I think ultimately the point is that, we will continue to see the expansion of these capabilities to, in particular, highly resourced threat actors who are, again, able to, put in the time and investment in order to roll extremely highly capable models. So we're not going to see an explosion of, kind of 15-year-olds who are able to run a Mythos class model on their gaming PC, right? We're much more likely to see, Chinese advanced persistent threats, increasingly automating attack orchestration, right? Increasingly able to more effectively discover and exploit vulnerabilities, right? So it's it's not a universal uplift in terms of capability that will come from open weight models, but, kind of benefits those who are best placed to exploit them.
Yeah, I think the other piece of this too that I think cybersecurity leaders need to be thinking about is you can't really rely on like this government sort of intervention, limiting access to very capable models to reduce the risk that you're experiencing, because these capabilities of these models, like sure, if Mythos and Fable are restricted and they've gone dark, you as a cybersecurity leader might like breathe a sigh of relief and say, oh, well, gosh, at least that capability is not in the hands of of threat actors and adversaries. But I think the point we're making is you really can't make that conclusion. And in fact, because this is sort of asymmetrical, as China's releasing open source models that appear to have similar capabilities to the ones you're restricted from accessing, for you to be on equal footing with threat actors, you now have to go look at these Chinese open source models that they do have access to, right? Because you can't just sort of draw the conclusion because Mythos and Fable went dark that threat actors aren't going to be able to use similar and same level of capabilities against you. And just, again, we keep bringing this up, but it's still important to say, this doesn't mean the sky is falling. There is still this expertise wall that getting real offensive value and performance out of an open source model or a frontier model, the vulnerability discovery, the exploit development, even the fix this code use case that seems to be why these models went dark in the first place. It still requires knowing how to prompt and scaffold and chain to be able to have the compute and the graphics card necessary for an open source model. So, the model doesn't replace the operator's skill, but it does amplify it. But, you're still going to have low skill users get, relatively low skill results. So, the scaffolding is where much of the real capability lives. It's not in the download. So there's still going to be an uneven distribution of the kind of threat actors that are going to get this uplift. But I think it's important for a cybersecurity leader to keep those things in mind when they're thinking about their strategy.
Well, that puts a wrap on episode 10 of the OWASP Gen AI Threat Intelligence Podcast. Rachel James, Dr. Bryan Nakayama, thanks so much. And I look forward to hearing from you on the next episode.
Cool.
Awesome.
Thanks for listening to the Threat Intelligence Podcast hosted by Rachel James and Dr. Bryan Nakayama from the Gen AI Security Project. This podcast is produced by the Gen AI Security Project with help from RumRunner Media.